Okay, so let's look at the question here on acceleration. That's going to help us understand some of the terms that we started off with. Terms such as your speed, your velocity. At the speed of 6 meters per second, it takes 5 seconds to stop and reverse at a new speed of what? 4 meters per second. So if you look at the diagram, it moves forward, stops and reverses, and starts to go back at a new speed of 4 meters per second. So you have to have a sense of direction here. So taking forward motion is positive. Calculate. So what does this imply? When we take our forward motion as positive, it means that our backward motion is going to be negative. But where is this important? This is important when we deal with vectors. Vectors such as what? Such as velocity. Okay, vectors are going to take into account the direction. They're going to be affected by the direction. So let's look at this question. Your change in speed is the first question. Calculate change in speed. The second one is calculate change in velocity. So change in speed is given by what? Your final speed minus your initial speed. So my final speed is 4 and my initial speed was 6 meters per second, and if I subtract there, I get a negative 2 meters per second. Now in the second question, we are asked to calculate the change in velocity. So change in velocity is equal to final velocity minus initial velocity, and my final velocity is now a negative 4 because the particle here stopped and reversed. So it's now going in the opposite direction to the positive direction. So it's a negative 4 minus 6 my initial velocity, and I get a negative 10 meters per second. So this is important to take into account the direction. Velocity is going to be affected by the direction. The sign on the value is going to be affected by the direction of the object. For acceleration, we just need our change in velocity over time taken. So our change in velocity was a negative 10 divided by the time there. We have a negative 2 meters per square second. And remember what we said, this is a negative acceleration. So it means the object is slowing down. The speed is decreasing at a rate of 2 meters per square second. So this is important. And remember we said that you can also call this a deceleration. Instead of calling it an acceleration of negative 2 meters per square second, you could simply call it a deceleration of 2 per second. A deceleration of 2 meters per square second, not a deceleration of negative 2. There is no negative deceleration. So it's a deceleration of 2 or an acceleration of negative 2. Let's go to the distance time graph. So you can plot your distance and your time, and remember that our definition of distance is that it's the total length covered throughout the whole journey. Okay, so we're going to look at some important properties of a distance time graph and then look at a graph. So when the gradient is constant or a straight line, the object moves at a constant speed. So when the gradient is constant or a straight line, the object moves at a constant speed. Firstly, you need to understand that the gradient of this distance time graph at any point is equivalent to the rate of change of distance, which is speed. So the gradient of this distance time graph is equal to speed. So when you see the gradient constant, it simply means constant speed. When it curves up, it means that the speed is increasing or the gradient is increasing. When it curves down, it means that the gradient is decreasing and hence speed is decreasing. When the gradient is 0, the speed is 0 and the object is at rest or stationary. When you have a horizontal line or the gradient is 0, it means that the object is at rest or it's stationary. So let's look at this on a diagram. So you have the first situation there, your curve is going up, the gradient, the curve is facing upwards. What does this tell you? The gradient is increasing, meaning that speed is also increasing. When you have your horizontal line there, it means that the gradient is 0 and hence the speed is 0, therefore the object is at rest. And when you have a linear gradient like that, it means that there's a constant gradient. So any point on that line, the the gradient is going to be constant. It means constant speed. That one is less steeper, the gradient is less than in the first case, therefore this is slower speed. Okay, this is slower speed, constant speed, but it's slower than in the first case. Then when you have it facing downward, the speed is decreasing because our gradient starts to decrease, so the speed is decreasing in the last instance there. Okay, let's look at a speed time graph, or in this case we can also look at it as the velocity time graph. So this graph is going to be the same for both speed and velocity. Okay, so again, it's a non-negative graph regardless of whether the object changes direction. So you see that it's always going to be on the positive side. Recall that speed is a scalar quantity, does not have direction. Negative speed does not give any meaning. So let's look at it. Let's look at the speed time graph, and then I'll bring in the velocity time graph later. So let's for now just look at it as the speed time graph. And remember, there's no negative speed, so this one is going to be unique because there is no negative speed. When the speed is at 0, it means that the object is at rest. You need to know that. When the speed is positive, the object is moving. Okay, let's look at what it tells you. So the gradient of the speed time graph will give you acceleration. Okay, the gradient of the speed time graph will also give you acceleration. Okay, so let's rush to the graph and look at what it means. So when you have it facing downwards like that, that's decreasing acceleration there, and when it reaches that minimum point, the gradient is 0, so that's 0 acceleration. 0 acceleration means constant speed. Okay, so when it starts to go up, your acceleration is increasing. Okay, increasing acceleration. When it's horizontal like that, it means that your acceleration is 0. So 0 acceleration may mean two things. 0 acceleration here firstly simply means that the velocity is constant. The velocity is constant. There's no change in velocity or speed when your acceleration is 0. So it's important to take note of that. It does not necessarily mean that the object is not moving. The object could be moving, but with 0 acceleration. Okay, and then when you have a linear a line like that, that means your acceleration is constant. That is a lower acceleration than in the first case, so that's a decrease in acceleration there. And when you have a curve starting to face down like that, it also means that there's a decrease in acceleration. And remember, the top there, the gradient is 0, meaning that there is no acceleration, and that's a negative acceleration or a deceleration. Okay, so let me bring in a velocity time graph so that we make a comparison here. Okay, so let's look at a velocity time graph here. There are going to be some important differences between this velocity time graph and the speed time graph. This is an example of a velocity time graph of a person moving with constant velocity. So the person moves here between 0 and 3 seconds at a constant velocity, and then moves again between 3 and 5 at a constant velocity, and then moves here. You can see that the velocity is 0, so the person is resting between seconds 5 and 8, and then now we have a negative value of velocity between 8 seconds and 12 seconds. What it means is that the person has turned around and they are now going in the opposite direction at a velocity of 1 meter per second. So this is one of the major differences. This one can have negative values. Okay, and you should also remember that the area under this velocity time graph will give you the total displacement, so we can calculate those areas there. That would be a rectangle, so area is equal to velocity times time, so you can calculate the total displacement for this